Manufacturing Matters is an MFG Radio Network production brought to you by GIE Media's Manufacturing Group as industry experts take deep dives into the latest manufacturing matters, whether it's new innovations, products, technologies, and emerging markets that help you understand better why manufacturing matters to you and also to the top companies in the medical, aerospace, defense, and electric vehicle manufacturing industries.
Hello and welcome to our latest roundtable discussion, Trends in Technology for Automating Operations. I'm managing editor Jake Kaufman, and we'll be joined by some of the greatest minds in manufacturing automation in just a moment. However, right now, we would like to thank our sponsors, Fanuc, Nikon, and FPT Industry. Fanuc Corporation was founded in 1956 in Japan. They started their journey focused on the development of servo motors and CNC controls. In 1982, Fanuc brought its technology to the United States in the form of industrial robots. Since that time, they've never looked back, and today Fanuc is the global leader in CNC systems, robotics, and robo machines with more than 40 million products installed worldwide. Nikon provides a variety of products, services, and solutions worldwide based on advanced optoelectronics and precision technologies cultivated during the company's more than 100 years of history. The group continues to create new values that contribute to improvement of quality of life and manufacturing in a wide variety of forms. And FPT is one of the largest Italian machine tool builders and has been in business of producing medium to large vertical and horizontal milling, boring, and turning machines since 1969. Based out of Venice, Italy, FPT's products serve a broad range of manufacturing areas like automotive, aerospace, defense, naval, nuclear, and energy sectors. Now, before we get to today's discussions, we also would like you to know the panelist a little bit better. We'll be joined today by John Toohey, the manager of business development for Fanuc America. He's responsible for the sales and account development for the RoboDrill team. He has more than 35 years of experience in automation and machine tool industries. Toohey joined Fanuc in 2016, and in his current role, he works with global end users and Fanuc integrators to help solve their customers' manufacturing industry or issues related to quality control, throughput, skills gap, workforce development, and profitability by applying the latest Fanuc technologies. We were also going to be joined by Frank Nuki, the machine tool integration product manager or program manager at Fanuc, but unfortunately his travel schedule has not allowed him to hop on today. So that does mean that John will get to talk twice as much, but Frank will be missed on the panel today. We'll also be joined by Paul Lightoller, the global product manager for the APDIS laser radar at Nikon, with 20 years of automotive, aerospace, and large trail metrology experience covering measurements, automation, and robotics, working with the laser radar products for more than a decade as an applications engineer. Paul has firsthand experience of the issues faced by customers across a wide range of industries. Now, as the product manager, he can take this experience and help drive new development for both the product and applications with the engineering team and integration partners to develop new approaches to production inspection during the using the automated capabilities of the APDIS laser radar. And finally, we'll be joined by Azil Vishwanathan, the Vice President of FPT North America. Easy started his career as a process engineer in the field of high-pressure die casting. After earning his MS degree in computer science engineering, Vishwanathan then worked as a controls engineer for FIDIA. He also joined FPT as its VP of Sales and Operations in 2015, covering the North American market, overseeing capital equipment sales activity in the United States, Canada, and Mexico, managing direct and distribution sales networks, and service and support, and customer engagement. So without any further ado, gentlemen, thank you so much for the time today. Who wants to talk about automation? Awesome. Well,
let John start.
Awesome. Well, John, we will start with you today, as the question is automation being used more in tooling and machining or for material handling, final assembly, etc.? Where kind of are you seeing the automation on the shop floor at the moment?
Actually, we're seeing deployments in automation in all areas across the shop floor, from unpacking your truck as things come in the building to packing that truck as it leaves and everything in between. But focusing on the machine tool integration part of it, in today's, we've heard, copious people talk about skills gap and the difficulty of finding employees. Robotic automation will actually supplant that employee shortage that we're going to have. So you're going to see a lot more machine tending operations on the shop floor, because at the end of the day, every one of us that owns a machine tool, we're not making money if we're not making chips. So the idea is to keep those spindles turning. And if we can't get people, robotic automation will be a great backfill to make sure that our spindles are always turning.
Well, thank you very much, John. So we go now to Paul with the same question. Where are you seeing the automation being used on the shop floor? Is it in the actual tooling and machining, or is it for final assembly, etc.? Where is it really being embraced?
So metrology in general has been used quite widely in the past, but now, yeah, we're and automation's always been around within metrology, but that's tended to be sort of more offline. You're taking a part to that metrology to do that measurement, which may or may not be automated. Now we're seeing a big trend to trying to put that metrology in line, actually in the production line, and that could be, that could be the assembly, it could be the manufacturing. That's where we're seeing that push for automation is they want to automate the metrology in line, make it a lot faster and make it work better to get better feedback and get better information where they are. But also, as John was sort of touching on, it's about also trying to de-skill that metrology as well. Metrology is seen as a scary thing. It's only for the boffins and the clever people in the back room. We're seeing, and we're trying to push as well, and we're seeing people want to be able to use it and just press a button. Press a button, give me an answer. Press a button, give me an answer. And that's where automation is being really powerful in the world of metrology, is to be able to do that. Yes, you still need the skilled people to set it up, but metrology is, by deploying it in an automated way, it's becoming much more usable and much easier to use by the people on the shop floor. They don't have to understand it; they just have to know, is it a good part or a bad part, and that's what they want within the automation in metrology.
And the beautiful part with attaching a Nikon camera to a Fanuc robot, this in-process gauging doesn't take away from cycle time and can actually help increase cycle time, because now you're not taking something offline to verify its quality. So the robot being the vehicle, the Nikon camera being the tool, the synergy between the two creates the solution that is needed in industry.
Yeah, and that's it. It's turning the metrology becomes a tool rather than something that's out the back. It's part of the production process, wherever that may be. You're checking parts as they're coming out of the machine, or you're checking parts as they're being put together, or you're checking them right at the end to make sure everything's okay. So it really is, wherever you can put it, people want it. And people want to, and make it as easy as possible. That's what automation is. It's about making life easy for the users.
Awesome. Well, thank you, gentlemen. And then Easy will have you wrap up this round of questions. Over at FPT, where are you guys seeing the automation being used on the shop floor? Is it in the tooling and machining, the final assembly? Where really is it being embraced?
Well, in a market in general, and I think FPT is also a kind of a subset of this, the material handling and the final assembly by far, I think, outscales the usage of automation quite a bit compared to the tooling and the actual machining per se. I'm talking purely in terms of tonnage and the volume of material handling, right? But not what we want it to be. So, but if we open it up as a broad case and talk about it, even on passive automation like work holding and clamping and things like that, I think that it scales up quite a bit also from a tooling and a machining perspective as well. It's just what we paint as the automation as a broader landscape is what is a case in point. But at the moment, it looks from a purely on a tonnage and the volume, material handling seems to be, and the final assembly seems to be outweighing the other two factors of tooling and machining. But I think the industry is gravitating more towards uh, utilizing more into the tooling aspect to make things more, try to make more abstract, let me say, because in material handling it's more repetitive. The size, the dimension, the weights are a lot more repetitive, but the tooling is something still. Payload plays a very important role in determining whether it is possible to be automated or not. So I guess that's where we would end up being eventually. But at the moment, I think to answer your question, the material handling and the final assembly seems to outweigh the usage of automation at the moment.
Thank you, Easy. So for our next round of questions, we'll go back to Paul at Nikon. Now, the main industries that we cover here at GIE Media include aerospace, medical, defense, and also electric vehicles. Are you seeing any of those industries particularly kind of really embrace automation? Is there any one of those industries that is using it more than the others?
I mean, automotive has always generally been at the forefront of heavy automation use, at least with regards to robotics and that, because they're a high rate product. They're producing vehicles as fast as they can, and they want to produce them very quickly, but they want to reduce manpower and reduce costs as much as possible. As most industries do. So automotive has always been very strong on the automation front. But it's only been fairly recently we've seen them take on the fully automated role of metrology, especially sort of in line. They tend to be fairly early adopters, but yeah, they've always been very strong and very willing to invest in the automation just to make life easier. They've got so high rates. Things like aerospace. Aerospace is weird, and I've always said that it's a very high technology product, but a lot of the manufacturing techniques have been quite old-fashioned. Even today, you can still go around a lot of aerospace factories, and there's guys with hammers and rivet guns and things like that. It's very manual. But they are, aerospace is becoming, and they're realizing to maintain the quality, maintain the integrity, and increase rate, they need to employ a lot more automation, and that's both from the manufacturing, but also, from metrology side. You've got to measure these things, and in aerospace, metrology is absolutely critical. Because if something fails in the air, as we've seen recently with certain other companies, it's very dangerous. So they have to make sure that everything is tested right, everything is manufactured exactly as it should be. And traditionally that's been people climbing all over it, trackers and things like that. Now they're going, we just don't have time to do that. It used to be if producing one aircraft a week, that was good. That was very fast. Now, they want to produce one aircraft every couple of days. So you need to have the automation in metrology to get in aerospace and really push that rate up. And that's what it's about. Automation in everything tends to help you make things faster. And that's really what we're seeing now. Other industries, electronics is big for us with our X-ray machines and things. That's, and again, it's because they need that speed. They need that constant throughput, but they need the quality and to verify the quality. So I would say, electronics is a big one for some of our devices, but aerospace is generally lagging behind in automation, but catching up. And automotive is usually pushing the boundaries at the forefront of what is possible in the big areas as far as we see.
Thank you, Paul. So Easy, we'll ask you the same question too. At FPT, where are you really seeing?
So from an FPT perspective, because finally automation is a function of two things. One is the payload, how much the gravity can handle, and what's the cost benefit ratio in terms of the floor space available. So my perspective is purely from an FPT, the size of machines that we make. The components that we do are probably average components, or the smallest components that we do are 80 inches by 80 inches, and then starts from there. From those components perspective, we see a lot more in the aerospace adoption in the aerospace sector. And we would like to see more in the defense area, but right now it seems more in the aerospace, because most of the components are aluminum, and which means that the mass of the component that needs to be handled is manageable. Let me put it that way. And the repetitiveness of the component is actually a more predictive phenomenon. So I know exactly what kind of sizes that I need to manage, what kind of near net part that I need to load as a raw block, and then what I need to machine out of it. And then the third important thing is, what is the time to set up, the ratio of the time to set up and the ratio of the time to the time to machine. So let's say the barometer is, I spend more than 10% of my times otherwise to set up a part over a 90%. There is, and again, it changes between company to company. So what I'm saying is not a yardstick, but usually when you take these ratios out and understand that, okay, my time to set up is X and my time to machine is 9X, then there is a case to understand whether I need to go to automate on that. It doesn't matter which areas. I would also add semiconductor to the whole spectrum as well. I know GIE probably doesn't cover at this point, but if you look at it from that standpoint, all these things could adapt. But at the moment, I think the adoption is more from an aerospace perspective, at least from our target market, right? From my target market, because the parts are repetitive. The tools that you need to use to machine those components are kind of predictable. The tooling in a way is still a tribal knowledge. You still need to know what kind of coolant works. People go with the smell, taste, and not taste, but smell and the feel of it. So it's still not it's still quite a bit of tribal knowledge. So they are little skeptical to go the automation route at the moment, but the adoption is certainly more in the aerospace sector, at least in our target market.
And Azil, do you see a sort of changes in that adoption and the requirements based on the new materials coming through, the composites and all that sort of thing? Is that changing how they're approaching and what they need from machining components? Are you seeing fewer machine components or actually more machine components now because they're understanding the materials better and trying to get more out of it?
Yeah, so it's a very good question. So they want to understand the material, but more than anything, it's not a matter of how efficient their processes are. It's more a question of predictability, and to know if I use the same tool with the same coolant and with the same material, am I getting the same results tomorrow as I machine the component today? Can I do it predictably tomorrow, so I know within a plus or minus 10% offset, I can predict the outcome tomorrow as well as I did today. In some sectors, they are able to do. Let's say it doesn't matter how many tools you go through on machining aluminum, but at least I know exactly how many tools I go through, which sometimes is not so easy to understand from, let's say, a job shop that's machining Inconel today to fiber optics or composites tomorrow. So the predictability aspect of it is not so easy to understand. So they find it challenging to do it. Yes, it will evolve, but I think it needs to be an organic growth between different areas. So it's just not the machine tool, just not the concept of automation, but also the peripheral technologies like tooling, the coolant, how everything comes together to make it happen. That's what I would say.
Thank you, gentlemen. Easy, we'll stick with you for the next round of questions. Now, how can automation make up for lost workforce and also improve the predictability and efficiency of the workforce that is in place?
I think automation is not something new. Ever since we had the light switch to turn it on and off, people wanted to do some kind of automation, right from the way it goes. So, and we just changed the terminology for quite a bit, and we changed the definition of it. But in gentle sense, it pretty much has been around for quite a while. But let me kind of answer this in a philosophical way. Uh, humans creativity always is naturally inclined to be a pro efficiency buyback, right? So if I did something with X amount of time yesterday, I really want to do it 90 in 10% faster today because I want to spend the extra time with my family or play games with my friends, whatever, right? It's naturally inclined, whether we like it or not, it's naturally inclined. The creative aspect of it is naturally inclined to the human psyche. In some ways, doing repetitive jobs is playing against this human psychology to be efficient, how I was doing yesterday to how I'm doing today and how I would be doing tomorrow. So repetitiveness or the task of doing repetitive things is actually counterintuitive to the actual human. So we want to automate certain aspects that frees up time for people to get into aspects that are more creatively, more enriching, and more rewarding for them to do from a human concept. But again, we can go over a lot of details in terms of when you talk about automation as how it's going to improve efficiency, time. There are lots and lots of aspects and how you do predictability, that those are tasks that can easily be managed as a repetitive thing with a fixed point of reference rather than needing a human capital to do it. And this will definitely, off whether we like it or not, the industry, because of our shared labor challenges that we have, it is a natural progression. Whether we want to force feed into it or not, it's out of our choice right now. And I think the sooner the adaptability happens, the better it is for individual organizations to be able to survive on a longer period of time. That's my 2 cents on it.
Awesome. Thank you, Easy. So John, we'll go back to you over at Fanuc. How are you guys seeing automation make up for a lost workforce or make the current workforce more productive and efficient?
Yeah, Easy covered a lot of that really well. And just to add on to some of the points he already made, if you're really looking at the companies that deploy automation, you can reach out to the A3, the Association for Advancing Automation, and they can provide you the statistics on the companies that deploy automation tend to be higher employed companies. They have higher profitability and more successful. The companies that have automated over the past decade have always been the leaders of their industry in what they're doing, because they've been able to, 1, control costs, 2, control their labor, and 3, at the end of the day, put out a part that is obviously of higher quality because it's made by automation and robotics, meaning that there isn't human intervention. A part wasn't forgotten because the robot does the same thing day over day. But where we're seeing automation deployed in general, now in my focus, I obviously focus in the machine tool world, but the emerging markets such as food, an enormous market that's coming. It's relatively green here in the United States. And again, this became extremely prevalent and predominant during the pandemic, when you'd see line at some chicken manufacturers, I can't say names, it's some chicken manufacturers where they have the deboning line, and you have people shoulder to shoulder on multiple tables that are hundreds of yards long. Well, you can't, that time frame didn't allow it. But what it did, it allowed some of these companies that are in food processing to realize that, wow, they can do just as much with automation and get a better product out the door. The other industry that is consuming robots is the 3PL, the DHLs, FedEx, Amazon, USPS, all these package handling companies. They are doing everything from out of the truck, sorting, mixed case palletizing. That is one of the largest industries, and the online consumption of products has skyrocketed, obviously, in the last decade. So, some of these companies are deploying even automation to get you down to the last mile with drones. So it isn't necessarily always robotic automation that is doing this. It could be autonomous vehicles. I'm in Phoenix right now, and had my first ride in a Waymo last night. It is very strange sitting in a car without a guy in the driver's seat. Cool, but strange. An experience. If you're in a Waymo city, please try it. It was an experience, and it was less than Uber. But automation, you're going to find it being deployed and even as Easy had said, when you get into pallet change systems where your tooling and work holding is being changed out, whether you're doing that with a person changing it, but you're still putting the fixture on a table that is accepting the automation, so the setup time is eliminated. Now, if you can do that with a robot, all the better. But even machine tool automation can be as simple as, pallet systems. Pallet changing systems are done automatically in many large systems. So what is really limiting us from the deployment of automation is really just the creativity of many of the owners and small shops that haven't been exposed to industrial automation at a large scale. As hard as we try, all of us on this call, we all try to get to our, to get to those shops that don't know automation, that don't know metrology, that don't know machine tools. And every day is a constant education. So as industry moves forward, you will see more and more of the non-traditional companies starting to get into automation. And then it's even going to get down into home automation, where you've got a system that'll put your dishes out of the dishwasher. You're starting to see restaurant automation already, where we affectionately call them flippy. But you're going to start seeing automation in fast food restaurants. It's already happening. Cali Burger. There's a whole bunch. Sorry about that. There's a whole bunch of fast food companies that are adopting automation, because again, when you look at the $15 an hour $15 minimum wage, if you're running 3 shifts in the service industry, the burden rate on that job is over $150,000 a year over year, with increases in cost of living and taxes. So you're looking over 10 years in a human position, spending over $1 million. You give an integrator $150 to automate that process, that's $150,000 up front, amortized over whatever your accounting team does. Plus, it's an asset you get to carry on your books. There is no benefit to using human labor over robotic labor when you look at the true cost over a period of time. So as more of this becomes adopted, you're going to start seeing companies become more successful, more profitable, because they are deploying people in a different way to support the automation instead of supplanting the people by the automation. I hope that was clear.
Yes, very much so. Thank you, John. Paul, we'll have you wrap up this round. Where are you seeing automation make up for lost workforce, or how is it improving the workforce that is already there, making them more productive and more efficient?
Yeah, I mean, John and Azil have done, they've talked about most of the key points, and they're all, those are the good arguments. The only thing I would add to that really is there's a lot of people tend to be a little bit scared of automation. They think, oh, it's going to take my job, or we're going to lose, workforce. We're going to, I'm going to be replaced by a robot. And it's like, well, to an extent, yes, but then you could look to be, reskilled and employed elsewhere. Someone's got to look after that robot. Someone's got to tend that machine. They've got to, the maintenance is not automated. So, the programming of itself, that's not automated. There's still requirements for the people to work on these things. But as John and Ezio said, it's not so much about replacing the people. It's doing that so then you can grow the company, so you can employ more people. So I think as John said, these companies that embrace automation, they've grown, and therefore they can employ more people to do these other jobs. So it's not you're not replacing the workforce. You're growing the company to make it better. And the other thing is, and it's almost our own fault. As consumers, we want to pay the minimum price. We don't want high prices. And the only way you're going to get low prices for most commodity type items is by automating. You can't pay, as John says, you can't pay $15 an hour to people, or if you want to have skilled work, you're paying 2, 3, 4, 5 times that. You can't pay that and keep your prices down. It's just impossible. So you need to have some way of reducing your costs, automating in that, so that you can keep those prices down, so people and consumers will buy more, which means you're going to have to invest more, your company's going to grow. So automation is sometimes seen as a horrible thing by people who aren't within the industry, but actually it's a way to grow. It's a method to grow, and also it's a method to stop very, very nasty, horrible injuries, which is the other side of it, which we don't, when we did a big study for aerospace years ago, and one of the things that we talked about in why automation is so good is because of nasty injuries, repetitive strain injuries, all these sort of things that come from somebody using percussive tools, or that hearing loss, eye damage, all these sort of things. It's another thing that automation can do. If you use a robot in a dangerous situation, the robot's not going to care if it gets hit or if there's danger. It's better for us. It's better as a workforce that we're not having to do all these repetitive jobs, because they become painful. So it's something that's sometimes lost a little bit, is, we want a better life. And to get a better life, we have to give over some of our, we give over some of that work that we do to robots, to machines, to other things to make our lives better, easier, hopefully cheaper. That's how I see automation.
We're also seeing the acceptance of a generational acceptance is completely different. Our generation, I'm Gen X. The Gen X generation, we follow the baby boomers, and those of us on the high end of the Gen X age group, we didn't grow up with automation. We didn't grow up with cell phones. We didn't grow up with computers. The generation behind us, they were given a smartphone immediately. And you know what? When they plug their smartphone at 6 years old into their iPad or their PC at 6 years old, they expect connectivity. So at the end of the day, we have to make our automation systems compatible to what the next generation is going to expect. And that is plug and play connectivity of automation to the machine tool, connectivity and ease of use and packaging and paint and welding. You see it a lot in the cobot space, where you've got cobots with lead to teach for welding. So it's also a generational thing that I think the next generation and the generation behind them are going to be more adept to using automation, because it wasn't something that was really a threat to take their job, and what was marketed very heavily against the automation industry in the 80s. I remember a story. My mom drove a Toyota 4Runner, and we were driving down Telegraph Road, which is a main thoroughfare in Detroit. And I was a junior in high school, and this guy pulled up next to her and started yelling at her for driving a Japanese car. But that was the mentality back in the 80s. And today that doesn't exist. I don't believe that I don't believe that even the UAW is threatened by automation. I think they welcome it. So at the end of the day, the transitional generational change is also going to help the deployment of automation, simply because these kids have grown up with automation in some form, literally since they could talk.
Just to add counterpoint, Jake, just to add a counterpoint to this, I don't want to be a killjoy, but actually automation is not for all the sectors, and not for even within a particular organization, not in all the processes, okay, at least at this standpoint. Because sometimes I also see this temptation to go automation, whether there is a need there or not. So it also adds, believe it or not, it also adds a level of complexity. Like Paul mentioned, it also needs to be maintained, that it also needs to be taken care of. And there are certain elements. So floor space is a necessary concern. So you got to be worried about what is my cost benefit ratio to have a pallet lying around that is going to occupy some space that I would otherwise not be using. What percentage of my floor space is a spindle? What percentage of that is automation? What is my cost benefit ratio? Sometimes those things need to play. So where it makes, from a human standpoint, from a human capital standpoint, our initial point of question is, those skills, like the process skills that people have to be first adopted by a human to understand that this is how my process need to transfer from one to another, and then you abstract it, which of them are repetitive and which of them can be automated. So the human element is very much into it, in fact a lot more than how it used to be, because once you strive for profitability, that you have to start with the human process, have a process plan in place, and then slowly automate certain subsets of those processes. It's in no way taking away human endeavor. It's just going to augment it in the interest of profitability. And that's how I see it. Automation is not for, at the moment, it's not for every place, and it's not like ad hoc thing where you decide to do and then do it. It's a very continual learning process.
Thank you. We'll go to John with the next round of questions. Now, how data-driven are these automation technologies, or, how driven?
Well, you froze again there, Jake, but I'm pretty sure it's going through. Actually, that ties in great to what Easy was just talking about with maintenance and understanding the connectivity. The advent of IoT and Industry 4.0 has really afforded the opportunity for companies and industry to look into how their automation and manufacturing processes are truly being handled. So when you look at, I'm going to speak about FANUC technology right now. I apologize. I don't mean to make this a commercial, but it is what we do, and it's what I'm familiar with. On the robot, we actually have an onboard software called ZDT. And what it does, it communicates with the cloud on a daily basis. And what we're looking for is statistical abnormalities from day to day. because we are so vertically integrated, we understand how our robots work. So we know what data to expect. So if we see a disturbance from a customer, meaning that something alerted was outside of the norm, we'll tell the customer. And our kinematic has been refined that we can define problems that are 6 and 8 months down the road. So using IoT and data can help us, one, perform our maintenance better. One, make sure our equipment is always running at peak performance because we're understanding how the internal components are working, and a problem doesn't come a problem until we can hear it or see it. So leveraging data to understand the health of in this case, the robot is paramount, and to keep your equipment running. It also gives you the operational insights. It can tell you, you can do it in red, blue, and yellow, red, yellow, and green on your lights. Where are my robots working? Where are my machine tools working? This same software, not a predictive part of the software we have on our CNC side called MT-Link I. And what MT-Link I does, it exports all this data, torque, horsepower, temperature, a whole bunch of information, just exports it to Excel. The reason we can't develop a kinematic is because our spindle motors go on to hundreds of different OEMs, so we don't know those data frames. But because of the data we can pull out over the, through Focus 2 libraries, we can allow our customers to now develop a baseline. I made a good part. Here was all my data that I needed to make this part. If I find a part that falls outside of this data, now all of a sudden I have a problem. My tool's worn out. I have a broken tool. The program, somebody changed the program, whatever. All of this is now available to us. So using data, connected smart manufacturing will be what drives all manufacturing, in my opinion, moving forward. A good operator can hear when the machine isn't performing correctly. And back in the day, that was enough. That's all we needed. But as Paul was talking about earlier, when you're cutting huge parts and you need to do some in-process gauging, you're working on a Blisk, those can be in excess of 6 figures. And if you make a mistake, that's a lot of scrap. So there's an advantage to using the data that I can pull from a metrology system to make sure. And we're starting to get into predictive toolpaths that I know that if I'm going to deviate even a couple micron off my toolpath, I will be able to stop the machine so I do not trash a $100,000 part. Data is key and king, and it will continue to be so moving forward. And I believe the other panelists will also agree that leveraging the data is going to be what can help us differentiate a good part from a bad part, and a good customer or a good supplier from a bad supplier.
Awesome. Thank you, John. So Paul, he did ask the question.
Yep.
Do you agree? Is data king when it comes to automation?
It is. I mean, I'm in metrology, in the metrology industry. Our output is data. That's what we do. We don't if you put metrology into a system, we're not manufacturing anything. We're not producing anything with the metrology other than data. And that's what can be used to derive the information. Now, in the past, metrology was seen as a necessary evil. It's like, we've got to put it in.
I thought it was witchcraft.
It's basically, it costs money, because why have I got this metrology in? Because it tells me I've got a bad part, so I've got to scrap that part. Or it tells me I've got a good part. Well, why do I care? I know I've got a good part, and you've just told me I've got a good part. So it's always seen as this necessary evil. It's going to cost money. Whereas now that's flipped, not flipped completely, but now it's changing. They realize that actually this data, if it's good data, and it's got to be good data, you can measure something badly very easily and get incorrect data. But if you trust that data and you're getting a lot of that data, you can then use that data to alter your process. So no longer is metrology just a check gauge. It's no longer a go, no go. It's no longer, do you put it in the bin, put it in the trash pile, or do you send it out to the customer? Now you can say, well, actually, we can see that this part's, okay, it's starting to get a bit worse. So let's feed that backwards. Let's change the process to bring it back in again. And it becomes a much more of instead of metrology being a hard cutoff, metrology is now guiding and adjusting the process as we go. And you can do that feed backwards, you can do it feed forwards, you can push that information on to the next stage. And that's where the data really comes into play. Because as Azia was saying, not every process can be automated. And some of the problem with that is not every process is repeatable. So how do you adapt and how do you change a process with metrology? You have vision systems, you have scanning systems, you have laser systems, all these sort of things are helping automation to be more adaptable and more flexible. And that's where we can get automation into more places, because it's no longer just, in the past, just a robot doing one single program, and if the wrong part came in, the robot would smash through it and destroy it. Nowadays, you can detect, is it the right part? Or, is there a slight twist on the part? You can go through, you can adjust as you're going along. As John said, if you've got a six-figure piece of metal in there that you're going to manufacture, it's like, okay, we've not quite done that right, but we can correct that and we can make some adjustments because we're measuring it, we're monitoring it, we've got that information, we've got that data. And that's where data plays the crucial role, at least from my side in metrology, is providing the information to the process. It's allowing you to be more flexible and be more, less scrap, less wastage, all that sort of thing, and just be more flexible in how you can deploy automation.
Thank you, Paul. So Easy, we'll go to you with the next round of questions. When a new client is looking at automating their production, what are some things that they need to have in place? What are some of the goals that they need to reach before they can automate a process?
So this kind of ties into the last point I kind of made. So is automation, is it organic second level of growth for my company or not, right? So they got to identify whether by doing this, this X amount of investment that I need to make, is it going to gain me without having me to unlearn and relearn a bunch of different things? We always unlearn and relearn, we always do it with our process, but what is the cost of it? What is the quantum of unlearning that you got to do to change from existing process to a new process? And that's something that that's the question that you got to answer. Second thing, we are still going to be constrained by the payload and gravity, right? So how big is the part? How much of a thing that how big the part is, and how much material handling I need to do? What is my cost of operating? What is the cost of? I have seen a lot of places where pallets are used like storage, right? You machine a part, it remains there, or before machining, parts remain there. They're not making money for you, right? So in that case, automation is not something that is going to help you. You have to make a very conscious. In fact, the oversight and the direction is more relevant after automation than before automation. So you got to know those kind of things. Just to touch down on the previous points of the data driven, and not to drag this conversation, I know we are short on time, but the element of data driven thing is to how to get into the decision making of it, the machine learning and the AI aspect of it. That is where the thing is. Right now, we are still in phase one of phase one. Other industries within the manufacturing spectrum have gone quite far. They're still in phase one, but they're probably of phase 10 of phase one. We are still in phase one, where we are collecting the data. We're still in the process of collecting data. So no data is too much. I think I agree with the rest of the panel. No data is too much. But when you integrate that data into the client needs to understand, the customer needs to understand whether this amount of data is going to be relevant, and this amount of automation is going to be relevant based on certain constraints. Do not do automation just for the sake of automation. You can start a passive automation, right? Like for work holding, it's a passive automation. You're not going to affect anything. And what is my takeaway from there? But there should be a very, very strong process narrative that was going to help this discussion to make the decision in favor of automation. It has to be an organic discussion. It has to be organic decision rather than a forced upon decision because maybe the investors want you to do. But it has to be tied into the goals of the organization, and that's how I would see it.
Awesome. Thank you, Easy. John, we'll go to you with that.
And automation, when we deal with customers that are new to automation, a lot of it is just the uncertainty, and I don't want to use the word fear, but people are intimidated. That's probably a better word. Intimidated by not understanding a program language. So the unfortunate thing is that today's worker, it seems that we're more adverse to learning something new when they've done it one way for a certain, but still expect all the new fancy features without having to do any learning. It's kind of a duplistic situation we find ourselves in, but we have been driven to things in the automation with ease of use. We go to a tablet TP with drag and drop icon programming. We can take the robot and we can lead to teach, and we can do all these things. to try to eliminate some of the fear or intimidation of what robotic automation can do. And this happens more with the operators on the shop floor. So what we're trying to do is to convince them that the robot is just another tool in your bag. So instead of being able to only man 2 machines, you can now man 5 machines. So now you have an argument to your boss and say, hey, I'm doing 5 machines. Shouldn't I get a little more money now? So it does give more value to the operator when you can do more and prove more to the company. So the barriers that I've seen from the new customers, intimidation is the biggest one. Once they understand what they're looking at, that intimidation goes away. The companies that sell this automation, we train people. We do a lot of hand-holding to make sure people are acceptance of that first piece of equipment they get, whether it's a CNC or a robot. Because at the end of the day, we've got to help educate the workforce that automation and robotics, it's not intimidating, it's not fearful. It's a highly complex engineered solution that is becoming easier and easier to deploy, and also more cost-effective and cheaper. I don't want to use the word cheaper, less expensive.
Thank you,
Just
John.
touch on John's topic, thought. So the automation has to be more of a bottom-up process. So it has to be sold to the, and it's also learning for us as a supplier. We got to sell it to the people who are actually using it. Right now, I think the saleability of this thing is top down. It has to be top down because they are the ones writing the check. But the sales process has to actually start as a bottom up process. Once they see the value in it, the adaptability gets even better. So that is where I think we got to change ourselves to from our salesmanship standpoint.
Easy's 100% right. So, there have been initiatives, and I've seen this at multiple large companies where they would buy a lot of 25 cobots and say, okay, let's find applications. That is not the way to deploy automation. The way to deploy automation is have an application, choose a vendor, find the right robot for that application, and then move forward. Today, unfortunately, we do see a lot of press in the media that there's a lot of cobot companies that go out and want to put their cobot into every single application. Well, if that's all you have, then that's what you're going to do. But at the end of the day, robotics and automation is about throughput, accuracy, speed, and safety. And if you can only get accuracy, if you can't get accuracy and all you really just get is ease of use, that's not what you want. You want to find a company that's going to have the right product to help you have a good experience with automation. And that goes everything from the pre-sale support to the aftermarket support. So if you're in the market for a robot, ask your person you're talking to, what are your methodologies to support? Who is your point of service? Is service free? Is there a warranty? What is the training protocol? Do you train? Who's my point of service? Who's my spare parts people? Where do I buy them? All of these are important questions. But the most important question you should be asking is, what is the mean time between failure between all of your components? Because if they fail, they're going to do you no good and you're going to have a bad experience. Those are all important questions to understand. Don't just chase the shiny object.
Awesome. Thank you, John. So Paul, we'll go to you with the next round. If you have an existing customer who is currently using automation, how hard or easy is it for them to expand it or even to, add to it or make changes to the operation? Kind of once it is in place, how easy is it to either expand it or change it?
I mean, a lot of that depends. It's very application dependent on that.
Right.
But once someone's bought into the idea of automation, especially with metrology, we see a lot of our customers will come back to us and say, well, we've got this now and we've been using it here, but now we know how it works. Can we use it over there? And can we do it this? And can we, they want to expand and really get into it. And that's the thing, is that barrier to entry. And again, it's stopping people being scared of it. Once they've stopped being scared of it, once they've embraced it, and back to Zill's point, from doing that from the ground up, the operators are the ones that will find the applications. The management don't know what the applications are. The management won't necessarily know this is where we want to deploy it. They'd say, we want to make it more efficient. The users, once you get them involved, they're the ones that will go, actually, we could do it over here. We've always had this problem with this machine. We don't quite know why it's happening. If we put this, if we put a laser radar in there and start measuring it, it will tell us the information we need. So we tend to find that, once they've started, they're hooked. It's a bit like a drug. They want more and more and more, which is great. They don't always want to pay for it, but that's a different matter. But they always want to they do like to have that automation once they've got it. But again, it's got to be the right application. It's got to be the right fit. And we'll quite happily, I'm quite happy to talk to customers and say, yeah, we've got, you've been using laser radar, you've got that application over there, but that's not an automated application. Or it's you need a different device, or you need something else to accomplish what you're trying to do. We're not going to, if it's a laser radar application, I'm going to push the laser radar, obviously, but I'd rather the user deploy something that's applicable to that, and get the right tool for that. And that may or may not be automation, but the customer does. We get a lot of customers coming back to us saying, yeah, we want to do this. Can we do this with your equipment? Have you got anything that will do this for us? So it is quite nice. Once they're in, then we see a lot of repeat orders, and a lot of repeat inquiries from the same people. Which is really cool. I think it does work within that way.
Thank you, Paul. So Easy, we'll go to you with the same question. Once you do have a customer who does have automation on the shop floor, how easy is it to change that operation or to expand that operation?
Currently, I think most of the automations solutions are geared towards, how I can expand it without affecting too much. How can I scale it up? But actually, it's an existential question, really. This question of scalability should be the number one question they ask in the beginning, before they even started going this automation route, because we all grow. Companies always grow. The whole point of growing is I want to knock this wall off and I want to put 4 machines this way. Sometimes it may be 4 machines that way. So the scalability question should be, even before you talk about profitability, the scalability is a very important question. But having said that, from an automation, like for pallet changers, are slightly more cost prohibitive to scale up if we didn't plan earlier ahead of time. Robots are actually a little bit more forgiving from that standpoint, because you can actually position them the way you want it, thanks to the teach pendant or the differential point of reference that you have with a robotic solution. You do have certain advantages. So to answer this question, it is first a question. If let's say I have made a decision that if I want to scale up like 80% and I already accounted for that, you are in a good space to expand out. In fact, it is actually more favorable to scale up. But sometimes you may be in a really tight situation, floor space wise, that you really cannot do. Even if you want to do automation, you just don't have the wherewithal to handle that. So there may be situation that, and I have seen them as well. So it is scalability should be the number one question they ask even before they got into this discussion of automation.
Yeah, I think, and I've seen that at sales is what we're putting in. Customers in the past, automation was seen as a very fixed and rigid thing. It can do one thing, and that's all you do. Whereas now it's like they want the flexibility. We can sell the flexibility of a robot system, or we can, by putting laser radar onto a robot, it's very flexible. Or we can take it off that and we can move it somewhere else and do something else with it. Or we can move it here and do something else with it. So that flexibility is the big thing, and that helps with scalability as well. But yeah, I think automation, the flexibility of automation nowadays is being a big driver to people adopting it and being willing to take on more stuff, because nowadays nothing, you're not going to manufacture the same thing necessarily for 20 years. You might manufacture it for, you might do something for 2 or 3 years, and there'll be a little change, or you have to change and go off in a completely different direction. So if you can reuse the automation that you've already got, that's a big selling point as well, I think.
Thank you, Paul. So John, we'll go to you with the next question. What are some challenges that a company might be facing with an automated system? Is there like a risk for hackers? Is there connectivity issues, software updates? Like, what are the kind of things that kind of end up bringing a automated operation to a halt?
Well, poor training of the people using the system is always usually a good recipe for disaster. But we have a lot of software built into our products to alleviate some of those pain points. We don't allow two-way communication into our robots. I can have, I can dial, anyone can dial into a FANUC robot over MT Connect or OPC, and you can get condition monitoring, but you're only pulling data. I cannot, there's a company out there right now called Olus Robotics, and what they're doing is remote access to the robot. And, most of the industrial companies are looking at that. But for the most part, FANUC's position is we do not allow any signal to go down into the robot or the machine tool that will start the machine, start the robot, start the program path, alter a path, program a path. None of that can be done externally. It all has to be done at a point of use at a teach pendant or the HMI. Now, in terms of the hacking on some of our IoT platforms, what we do, everything in our ZDD platform, it's bits of information and it's encrypted. So we don't put any process or part information into our ZDT product. That is only empirical data coming out of the RV joints and the controller from the robot. So we do not have the intrusion fears from hackers or anybody that's going to come in and take control of 400 robots on a plant and robots just start swinging all over the place. That cannot happen. It's designed so it cannot happen. Now, moving forward, when you get into these companies that want remote access, I know our people are talking to them. I don't know what FANUC's official position is on remote access at this exact moment. But traditionally, we do not allow any access or control path to be changed outside of the teach pendant or HMI on the machine tool. So we don't have that concern today of hacks and intrusion.
Okay, thank you, John. So yeah, Easy or Paul, if there's anything that you guys wanted to add about challenges to having a automated system, you guys can chime in now if either of you guys have.
John touched this very important point about data privacy, and which is very relevant. But one of the things from our standpoint and my target market standpoint is sometimes we also cannot be over reliant on the automation part of it, in the sense that we tend to forget things very quickly if I don't do it on a very frequent basis. Let's say I get into a tooling world, I start using palletization solution to do all my machining. All of a sudden, but that's a single point of failure. Whether we like it or not, automation, you spend about, at least in my target market, we spend not more than 20% of my investment into automation via the spindle, the machine itself. So if I have a point of failure on my automation, I cannot afford to have my spindle sit idle. Now the problem is the people suddenly lost touch with whether by process, by design, or by lack of knowledge, they don't know how to load the part, they don't know how to run it, how they have done it in the past. So now it's not producing. The fail-safe mechanism of this has been defeated. So I think companies got to do some conscious effort not to lose that element of handling it themselves as well, because there is an element of risk of something that costs is 1/5 of the total investment that's going to shut down your production. You don't want to put yourself in that standpoint either. So the company's got to do some conscious effort in also mitigating those risks. That's what I would add to what John just mentioned.
Yeah, and I don't think it's something that's obviously not limited to automation. It's hacking. We've all got phones, we've all got laptops. We're all connected in this connected world. And that's why, those companies are creating standards and creating ways of stopping it. You're never going to stop it completely, but we use off the shelf equipment. We use Windows PCs, we use standard PLCs, we use standard robots. What we're doing, we've developed our own thing for doing the metrology and measurements, but around that is a load of standards. It's a load of known software and interfaces and processes that we have to use to make sure that we're complying with all the regulations and all the safe things to prevent these things happening. The worst thing you can do is go away from those standards if you don't know what you're doing, and that's when you become vulnerable. It's when you're trying to be too clever or think, I can do it better. So a lot of the time, if it exists, let's use it. Let's use what's there, and that's how we can protect ourselves. Is just by using what's around us rather than trying to think about it. We're never going to prevent it completely. We're always going to be susceptible to it, but there's a lot of lot of ways of defending against those things, which are no different to anything else that's connected out there. So let's use the same tools, use the same information.
Thank you, Paul. So we'll actually stay with you to start wrapping things up. The final question that I have for each of you today is, what automation technologies are you seeing, with promise that could be coming in the future? What's something kind of down the line that you expect to see in the world of automation that you could be excited about, or, that you're just really, hoping to see here soon?
So for me, it's really just the bigger adoption of metrology embedded into things. It's that integration of the metrology as part of the production process. So that's really doing that, and all this sort of thing, better information, better data, a little bit of touched on mentioning about AI and things like that, which may seem a bit weird, but not so much AI as such, but just using the data and the amount of data we can provide to actually look at the processes and modify those processes, making everything more flexible by having the information. So yeah, not necessarily AI with the fact that robots are going to suddenly start walking around and taking over the world, but more in the fact that with all the data that we can now provide and the good quality data, we can look at the connections through. We can look at those interconnections. We can look at the patterns. We can see where things are going. And I think that ability to look at the patterns prediction, make things just more efficient, as John was saying, Fanuc is sort of doing it at the moment by, they're doing active monitoring and predictive monitoring of what's going on. I think that's really where the whole world, especially with metrology, we're going to see a lot more. That's where the excitement is going to be. It's the software development. What do you do with the data that we're providing? I think that's going to be the interesting thing going forward. It's the new ways of utilizing that data to help our customers get the best out of their automation.
Thank you, Paul. So Easy, we'll go to you as well. What is something in the future that you see coming to the world of automation? What's something that you're kind of excited about or that you would like to see?
I think currently we have a fairly well-defined automation thing. I mean, the question is also always a question of adaptability. But in the future, I foresee a lot of data-driven in terms of machine learning and artificial intelligence, purely from a decision-making standpoint. Because right now, that is the only thing that's creating a certain amount of bottleneck within a process, within an organization, as the materials flow through. So and decision-making is not yet a very integral part of the automation that is being provided as a standard. I mean, outside of the robot spectrum, I'm talking about like a machining standpoint. So decision making is going to be very critical. I think that is where, based on certain failures, certain aspects of doing, there was a certain aspect. How do I correct myself? How does the machine correct itself or adapt itself in terms of certain inefficiencies and cover that so that my final output is at least not stopped. Maybe it is doing it in a less efficient way. That decision making needs a copious amount of data. And we are still in phase one. We are acquiring the data. We'll get to the next phase where we know now we have too much data. Who's going to separate them? And then we get into the evolution of how to find this relevant data and take the quick decision making. And that's going to be tied in with machine learning. And I think in the next 20 years, that's where the development is going to go to, decision making on finite elements. That's where it's going to be very, very, very crucial.
Thank you, Easy. And then John, we'll have you wrap things up today with the discussion. What, in the future, are you seeing potentially coming to the world of automation, or what do you expect to see? What are you excited to see?
I'm excited to see a lot of different things. I'm going to start out speaking in the machine tool space because that's my house. Ease of connectivity and plug and play connectivity from robot to machine tool. I think the faster we can deploy automation, the easier we can deploy it. Also with the advancements in the ease of use programming technologies, whether it's drop and drag from a teach pendant or a lead to teach from the robot itself, all of these technologies will start to be more prevalent in industry, and you'll see more robots deployed that way. I'm also very excited to see robots starting to be placed on AMRs. When you start placing robots and AMRs, now you're truly adding functionality to a vehicle to give it sight, to give it feel, and to give it obviously the 6-axis articulation on a machine tool, or excuse me, on an AMR, to tend a machine tool, to take a package, to deliver a tote. It doesn't matter what it is, but I'm very excited to see where the marriage between AMRs and robots go in the future. I think that's going to be one of the biggest changes we see in the forthcoming years from a robot perspective.
Awesome. Thank you, John. So that just about wraps up today's roundtable. But once again, I would like to thank Fanuc and John Toohey, also Paul Lightoller and Nikon, and also Azil Vishwanathan and FPT Industry. Gentlemen, thank you so much for your time today, and I hope you guys have a great rest of your day.
Thank you, everybody.
Thank you very much.
Thank you, Jake. Thank you.
You can listen to all of our episodes of Manufacturing Matters and Lunch and Learn podcast from the MFG Radio Network on Spotify, Apple Music, and on our websites, todaysmedicaldevelopments.com, aerospacemanufacturinganddesign.com, defenseandmunitions.com, and evdesignandmanufacturing.com.